Hello, good morning, everyone, and welcome to our webinar, The Journey to Sustainable Data Centers. This webinar is organized from Johnson Controls in cooperation with DC Pro. Thank you for taking the time to attend this webinar this morning with us. So my name is Agnese Lamorte. I will be your moderator during this session. I'm a business development manager for Continental Europe in Johnson Controls. Before starting, these are a few rules for our webinar. So all participants are muted, so you do not have the chance to speak. But indeed, we will highly appreciate if you can ask a question, whatever needed. All the questions will be answered at the end in our Q&A session from our experts. And then just a small reminder, at the end of the webinar, we will ask for a very quick survey in order to really collect the feedback of that one. Let's move now to our poll. So we would like to ask you a very quick question before starting. The poll is related to the using of ESG reporting software to reduce energy consumption to your data center. So are you using this ESG reporting, yes or not? Please submit your answer. Right, so few seconds more to collect all the answers from you. At the moment, we do have the majority that are not using the ESG reporting, and only 8% at the moment that are using. Perfect. I think this is the answer. So only 8% are using the ESG reporting, and the majority are not. So let me introduce to you today's speaker. We will have with us a very important experts in the sector for data center. The first speaker for today is Mr. Hessam Seifi, Managing Director for DC Pro. And then from Johnson Controls, we will have Jan Meyer, Director for Sustainability for Continental Europe, Christina von Westernhagen, Director of Government Relationship for Continental Europe, Drita Gashi, BMS Solution Manager for Continental Europe, and Lucia Favuzzi, HVAC Solution Manager for Continental Europe. This is the agenda for today. We will start with Hessam, that will introduce to us the roadmap of sustainability for data center, followed by Jan, that will make an introduction about why sustainability is a key topic for this vertical for data center, followed from Christina, that will introduce to us the policy trends. And then we will have Drita talking about the importance of having controls on your data center for sustainability. And we'll conclude with Lucia, last but not least, gain energy savings and maximum uptime for your data centers. Saying that, again, thank you very much for taking the time today. I'll hand over to the first speaker, Hessam. Enjoy the session. Thank you.
Thank you, Agnese. Hello, everyone. In this session, we're going to discuss about the sustainability in data centers. There are some brief topics that we're going to discuss in this session as follows. The next slide. In this session, I'd like to discuss, first of all, what is sustainability? And then we're going to touch environmental sustainability strategies, why sustainability in data center is important, what are the key drivers of sustainability in data centers, then challenges, and what are the first steps and the roadmap of this journey to sustainable data centers. And at the end, we give you some examples of some current trends and success stories in this area. What is actually sustainability? Sustainability back in the 1980s was defined by the United Nations Brundtland Commission as meeting the needs of the present without compromising the ability of future generations to meet their own needs. This is a very important as a core meaning and true meaning of the sustainability that we always need to keep in mind in any areas that we are working on. And it has three main pillars of this, which is economy, society, and environmental, to achieve that main goal. And it is very important to know that, as it was even defined, it's very clear that there is no one solution of sustainability for all of the areas, because actually the economics and social systems, ecological conditions are very different in different areas in different countries. Each country and each regions may have their own policies and priorities, which makes it very difficult, should be also taken into consideration. And last is that as a final goal, we need to make sure that the sustainable development is seen as a global objective, so although that we have regional importance as well. In this session, our main focus is on the environmental sustainability mainly. And by environmental sustainability, what do we mean by environmental sustainability? Environmental sustainability is a rate that when we are using the energy resources, whether they are renewable or non-renewable, and at the same time we're polluting the environment, we can keep that state indefinitely. And that means that we put no harm to the lives of the risk to the lives of the humans and other living organisms. So this is very important to have in mind when we are considering the environmental sustainability. And there are a few strategies here that you can see in order to meet that goal. Is biodiversity preservation, regenerative capacity, circularity. Resiliency is very important to make sure that our designs are lasting long and we can make longer lifetime of the equipment. Renewable energies by limiting non-renewable sources, reducing reducing emissions and waste, minimizing transportation, and last but not least, which is also very important, is to have a continuous improvement in that journey. Now we're discussing, sustainability, as mentioned, is a global thing. It's applicable to all industries, and why data center as well is also important. To know this, we need to understand what role data centers play in terms of the energy consumption in the whole global energy market. As per different reports, the total volume of the energy that data centers are consuming globally is somehow between 1.5 to 3% of the global electricity energy, depending on different reports. And just we tried to give you an idea of the scale of this as of now. It is the total global energy consumption is somewhere around 23 to 24,000 terawatt per hour, and the 2% of this, the average, will amount to 500 and somewhere around 530 terawatt hour. And that is very similar to what Germany as a country consumes. So to understand that if we consider all of the data centers in the whole world, they are consuming very big chunk of the global energy consumption. And that is just now. And because the growth is really growing exponentially, that makes it even far more important. And there are two other things that when we consider sustainability of a data center is that we should not see data centers as something negative, that we should control them, they should be sustainable. Of course, that's important, but also I'd like to highlight the positive side of the data centers, because they also give some positives to the journey of sustainability. For example, by we use data centers to solve our mathematical problems for global climate change, are all as a result of having supercomputers running at a data center in some sort, or having these webinars and discussions how to help the environment is also with the help of the data centers. So in a way, the advancement of digital economy itself also plays a positive role in the journey of the sustainability. And what are the key drivers of sustainability in the data centers? I think these are the, let's say, not all, but among the most important key drivers. One is the end users and customers. I think they have the big say of the sustainability, they can start because I think that the customer can start asking for those energy efficiency and sustainability, let's say, requirements when they are moving to a data center, let's say in a co-location business. So by adding those in their contractual requirements, demanding those, they will actually pave the path for more sustainable data centers. They can drive the market. Then another important one is government policies and subsidies, such as in Europe, we have Green Deal, taxonomy, and green finance. ESG factors and sustainable investments. Individual and organization commitments also play a big role. Public opinion is another key factor, and business competitiveness and continuity, which have to be taken into consideration as drivers. In this journey, we have many challenges, and a few of these challenges that we need to be aware of are as lack of standardization in reporting, because there's lots of topic of PUE, which is not a factor of sustainability, but it is one of the metrics, which is important. Unfortunately, there's not a very standardized way of PUE as of now in the industry. There's lack of monitoring. Actually, in the latest report by Uptime Institute, they have found that 82% of the data centers, they track electricity usage, and a big portion of them, they monitor power usage effectiveness, but only 1/3 of them, they monitor the carbon impact. So that shows that a very small group of, let's say, a small percentage of data centers are currently mindful of their carbon emissions. Not stringent enough policies. We would like to avoid greenwashing, lack of knowledge, expertise. Policies and movements sometimes by the organization, they do not, unfortunately, have holistic view to understand the whole life cycle. Economics plays a role, lack of adequate incentives and subsidies, clarity in supply chain and material production, education, and reluctancy to change. And we need to understand also design versus operational performance. What is designed is not necessarily, we need to keep an eye on it during the operation, and also somehow encouraging the organizations to disclose their GHG emissions in their reporting. What are the first steps and the roadmap for this journey? One of the, I think the most important steps is to have some metrics. There are some available metrics like PUE, is power usage effectiveness is one of them. We have WE, these are the good starters, but again, needs to be standardized. So, but that is key to have some metrics as a goal, as a KPI. And it's not limited only to power and water. I'd like to call it XUE. It could be anything. It could be data usage efficiency, carbon usage efficiency, effectiveness, sorry. And another step is to have a holistic approach for the carbon footprint. If you look at the GHG protocol, they are addressing this in 3 different scopes, from scope 1, scope 2, scope 3, where you see your carbon footprint, either at the facility itself, or you take into consideration some indirect energies as a result, or considering the whole supply chain, from including business travels and the value chain, which is by itself a separate topic. I don't like to go into the detail of it, but it's very important to have a holistic approach, so we're not limited only to the facility itself. We should see the whole value chain. And also, it's very important during this journey that we be mindful of the goal of the sustainability in all of the life cycles of the sustainability, from having an idea, planning, up onto the decommissioning of the data center, sometimes is not given enough importance. I'd like to also spend some time here to, because we touched on a few of these sustainability metrics. One of them is a PUE, which is a power usage effectiveness, and WE, water usage effectiveness, because there is some, I see that it's been used a lot, but there is not very well understood, and it's very good to understand the actual meaning of them. Originally, power of PUE was defined as a power, but now in the industry is more used as an energy, which is, I think, is good. But it's very important to know that this can have different meanings by the way you report it or the level that you do the measurement. this should be standardized. Some people can measure the let's say energy at the output of a UPS or the output of a PDU or at the IT equipment. So it can come with a different PUE values which are not, let's say, comparable with the other one. So it's very important to standardize it. But as a true meaning, as a meaning of it, it's very important to know that it is the total facility energy divided by the total IT equipment energy used in a period, usually 1 year. But again, it's very important we understand that it has different intervals of reporting and different levels of reporting. We should not be taken for granted. And another metric of it is WE. As we touched previously in the GHG protocol, there are different scopes. That's also very important to understand that water effectiveness is not just to look at site. We have a metric for that, which measures the annual site water usage, which is only at site divided by the IT equipment energy. But that's just similar to what Carbon Scope 1 does. But to have a more holistic view, it's better to see it as an annual source of, let's say, water, not just at the site, but at the source as well. Then that would be a more, I think, more appropriate way of seeing it, because just saving water at site does not necessarily mean that you're saving energy and carbon emissions. There are a few strategies that I'd like to highlight here in this journey. One is we need to focus on reducing obviously our carbon footprint. Life cycle assessment, we need to combine both the robustness of the life cycle assessment methodology and the principles of circular economy to have a proper holistic approach. Increase efficiency, not just IT itself, but also the non-IT operations as well. Adopting renewable energies, directing investment to sustainable projects. Waste heat recovery is also an important topic. Having data centers in brown fields rather than green fields will also lead into a more sustainable project. And then another thing which I also think is very important is to find synergies with the other industries and other facilities, and because data centers can come next to another facility and have better synergies next to them in order to exchange energies. Waste heat can be more efficiently exchanged and other metrics, which is can be a separate topic by itself. Using AI is also another important topic when it comes to the sustainability, because that not only we have data centers for the artificial intelligence, let's say, platforms, but we can also use AI in the infrastructural optimization to optimize the energy and optimize our sustainability metrics. And there are the other, I think, strategies that I think there's not much time to go through them, but basically energy storage solutions and circularities is also another important strategy in this regard. And at the end, I'd like to also say that there are also some good news. It was that already the industry is looking at some of these strategies and new innovative ways of doing it. One of them is just like major big companies and cloud providers such as Amazon, Microsoft. They have their own commitments, which is announced at the organizational level to become carbon neutral and carbon negative, some of them by 2030, as early as 2030. We talked about heat reuse. There are examples of heat reuse applications already in Europe, like in Nordic countries and Netherlands. There are already examples of that. Hydrogen fuel is also as another innovative ideas. It's been there. The idea is not new, but it is recently being used in data centers that we have examples of it recently, and to a smaller scale, although in the Netherlands. Now I'd like to pass it to my colleague Jan to discuss about the next sustainability topics.
Thank you, Hassam. So I will present a bit why sustainability is such a key topic in data centers, and really looking now to bring you the view of Johnson Technology and Johnson view on data center. Here you get a bit of presentation on path to net zero for data center, and what we really want to bring as message is technologies are there. We have today all building technologies to be able to handle and move to zero emission data centers. How do we look at it? We look at scope 1, scope 2, scope 3, like Hesam presented. Scope 1 is first suppress fossil fuel combustion systems. Okay, move to full electrified systems, including backups, including connection to the grid, and really looking on site to have only electrified systems. The second part is, as you know, data center needs cooling, need a lot of cooling, and there's about refrigerant, using properly the refrigerant, reducing the quantity of refrigerant, and avoiding any leak on site to avoid any emission out of it. And the second point is really about the energy, okay? And thinking about brownfield data center included in the smart city, working with other industries around, working with district heating. I mean, district heating would bring, for example, 6 months during the year where you reuse the heat. And if you reuse the heat, it gets a higher emission effect than if you, for example, just reduce a bit the electricity consumption. So really, you can have 80% of the waste heat, like we called it in the past, move to something which is really energy for other industries, for other cities, for other buildings around. And the second part of the equation is we think data center, and the last ones which have been built have been really oriented to that, can start to be a microgrid hub for the electricity of a smart town, of an area, of other industries, and really working with solar energy, PV energy, including other buildings around, other surface, land owned by the data center itself, can really bring additional renewable energy to the city and reduce the emission of the data center. The second part on scope 2 is really what most of the data center are starting to do well, is really purchasing green energy. But as you know, green energy is still limited. It's not 50% of Europe energy, so typically there will be shortage there. You can't use all the green energy for cars, for real estate buildings, and for data centers. So there's a competition, and there will be even high price on these PPA contracts, and also high price on offsetting systems for that. So that scope 2 is something which will move, but as long as we don't have, let's say, 90% of energy in Europe renewable, it will be a hard conflict between the different industries. And scope 3, I think, is emerging as a new topic. I think the point here, I would bring 2 topics. One is the construction of the data center, how to simplify the construction, but make it more isolated to bring, let's say, the best for future circular economy. How could we use some of the material in 10, 15 years when the data center will be renovated? And the second part is water consumption. As we spoke about cooling, very often we use water for this, and water consumption can really bring some environmental effects which we need to reduce. So here, big message, technology is there, but you need to change the design. It's not about just changing some products or equipment. It's about thinking about the data center in the smart city to make it net zero. Next page. So here, I don't want to bring the challenge that Hesam brought. I mean, the evolution of data center, including edge device, including mobile device, is really running exponential. Today, worldwide data center are already emitting gas emission like Germany. And if we continue on that scope, so that's why there's a big challenge and it's a big topic, it would even compare to a complete continent in 20, 25 years. So it need to rethink how the business model of data center is working. And it's probably one of the most complex vertical market because it's growing, and we want to use all these digital services, but it needs to grow in a sustainable way. And for that, 4 directions we need to think. First, I mean, if we look at as Johnson, a data center is a heating plant, okay? Thermodynamically, basically, a data center is producing data, is operating data, but thermodynamically, it's a heating plant. You put electricity in, you get heat out, and you need to reuse this heat as much as possible, because that has a huge effect on the sustainability of data center. The second point is data center and new construction. You can really integrate renewable production into it. I mean, on the roofs, on the carports, on areas around, and create with energy storage a really microgrid hub, which can work for the data center itself, but also for other industries, for towns around. I mean, really thinking about the renewable production around the data center and make it more and more renewable. The third point is think about circular economy. I mean, data center have a life cycle which will not be 100 years like other buildings. So it needs to be designed for renovation in the future, for renewable construction material, and thought how can we change it for the future, etc. And the last point, I think Hessam wrote it already, PUE is important, but it's only a first step, okay? It's just measuring how much electricity you send to the site versus how much electricity are your servers using. But if you, let's say, improve 10% of the PUE, it's a lot less than if you reuse 50% of the heat. Okay, so heat is a huge topic for data center, and reuse of the heat is a major path for zero energy. So my last point is mainly here to bring up the Forester. You see the link below. So we have a survey we sent to data center decisionaires, and you see it's a mixed result of the surveys. On the one side, when we see the global pledges of the different decisionaires, it's not that high going to net zero. Okay, it's even less than for the global survey we did for all type of buildings. So it's still a need for awareness about the technology which can bring it, and also awareness about this new design, thinking about data center. On the other side, we see on the right that this decisionaire have put a highest increase in the rank to sustainability. I mean, I think that's the topic which is the most important in the future and increasing important for data center. So we see this movement to sustainable awareness and really bringing up zero emission data center in the future. So please, you will get this presentation afterwards and this link, and you can search directly on internet on this Forester survey for Johnson Control survey. Next page. And I would like to present one digital solution we are going to bring during this summer, which is called OpenBlue Net Zero Advisor, and which really helps you to look at the complete ESG reporting. But it's not ESG reporting that you fill out with Excel sheet, you need to re-enter. It's really something which is embedded in the data center building, in all the equipment, all the connection. And the first point is really to report, okay, to be able to give the CO2 emissions you have today, you will have tomorrow with a certain weather, with a certain operation, getting the tracking, the complete history of data, why this equipment was less efficient in this period, why should I maybe concentrate on this type of servers versus this one. So that really having a tracking, dynamic tracking of the CO2 emission versus the operation, and the management of it with the optimization software. How do I optimize my solar photovoltaic on the roof versus my consumption? What should I store? Should I store, for example, cold water? Should I store electricity? All this management of the building directly embedded in the complete digital solution. OpenBlue Net Zero Advisor, we will start a campaign in the next weeks to really bring this solution to the market. So that would be my last slide, and I would like to introduce you Christina, which will show you the policy trend and the policy landscape around data center in Europe.
Thank you very much, Jan. Thank you very much for everyone attending this webinar. We will now take a closer look at the policy environment in Europe and how the policy environment will actually drive also sustainability for data centers. A quick introduction, I'm Christina von Westernhagen. I represent Johnson Controls at European level. And EU policy is actually a key driver for more data center sustainability. And let's take a closer look what it means. So we have here in Europe the EU Green Deal, which is the policy flagship program set by the European Commission from 2019 to 2024. And Europe is unique in the world and has already had a very good effect on other regions, and that Europe has set itself a target to be net zero by 2050. To break that down and to get there, Europe has also put specific programs on place. One program is the renovation wave, because as we all know, the energy demand from buildings is very high, and buildings consume 40% of the energy that is consumed in Europe and also worldwide actually. And also in Europe emit 36% of the greenhouse gas emissions. So buildings and looking at buildings is actually a low-hanging fruit for the EU to get to net zero. But then, and that's why the EU has also set itself a target to renovate buildings more with the EU renovation wave. But what we also have done in Europe, and we are at this point in time ahead of other regions, we have adopted last year the EU climate law. And the climate law sets a binding legal commitment to be more on the path to net zero by 2030. And the EU climate law says by 2030, we want to reduce 55% of the carbon emissions as they were in 1990. And to get there, the EU has put together a package of 12 legislative pieces that helps the EU to get to the target of reducing 55% of the carbon emissions by 2030 as they were in 1990. And there are two pieces of legislation very critical for us. One is the Energy Performance of Buildings Directive, and for data centers, you also have the Energy Efficiency Directive. Let's take a look at the next slide, please. Agnese, can we have the next slide? Could we advance the slide, please? Hello? I'm sorry, but someone needs to advance the slides. Thank you. Excellent. So let's take a look at why data centers are really important from an energy efficiency perspective. You see here this slide, which is actually coming from the European Commission, that precasts the energy demand by data centers. And you see here the current scenario, a trend, the expanding edge of data centers, and then perhaps the most efficient scenario and the worst case. So you see there is a big gap at the end when you go to 2030 between the worst case scenario and a very efficient data center. And to address this gap, the European Commission is now working to tighten legislation to tackle the huge energy demand by data centers and to make data centers more energy efficient. So how is this done? Let's take a look at the next slide, please. Agnese, could you please advance?
Can you see the slide correctly, Christina?
Yeah, slide number 27. If you could please go to slide number 28. Thank you. So the European Commission is currently working on a recast of the Energy Efficiency Directive. And the Energy Efficiency Directive is very important because 80% of the energy use comes from buildings comes from heating and cooling. And what the Energy Efficiency Directive is doing is it says industries need to find synergies with other energy industries. And data centers have been picked by the European Commission as an industry that needs to find synergies with other industries. So that's one very important aspect. Decarbonization of heating and cooling and synergies of data centers with other industries. But then also what the European Commission is planning is really looking at a new set for heating and cooling coming up under the Energy Efficiency Directive. And that's why it's so very important to look at the Energy Efficiency Directive, because it will formulate new requirements for higher efficiency in heat generation should be extended to the energy supply and to the installation of data centers. And because this is a trend coming up, the industry has already reacted. So we are looking here at the existing laws that already look into data center efficiency. We have the eco-design regulation, we have the EU Code of Conduct for data center energy efficiency, and also green public procurement. So the trend that data centers need to be efficient is already enshrined by existing law. And the Joint Research Center at the EU level has also already adopted best practice guidelines and a code of conduct for energy efficiency of data centers. But more is to come. Next slide, please, Agnese. Thank you. So we also see new upcoming law. We have already looked at the Energy Efficiency Directive, which will introduce new elements to improve the energy efficiency for data centers. We also mentioned already the taxonomy regulation. And the taxonomy regulation is the European law that will define what is green to avoid greenwashing for data centers. And the energy taxation, the European taxonomy regulation has one chapter that talks about energy efficiency, and there may be also a reference to data centers coming up. So there will be a closer look at what data center efficiency looks like. And if a data center owner does not use a technology for the data center that is falling under the energy efficiency criteria of the taxonomy regulation, the company cannot no longer call itself using green or doing green business. And that has a ripple-on effect for investors who try to invest in green stock. But then what is also really interesting now in the EU is that we have a lot of underpinning funding programs that also provide help to data centers, because they have to connect to other industries, because they have to perhaps also use the waste heat from others. So there's funding around to do so. There is the Horizon program, the Connecting Europe facility, but also very important, the Recovery and Resilience facility, where the European Union has put together 750 billion euros to be used by 2026 to enhance energy efficiency and to advance the EU Green Deal. So there is money to be claimed to actually also invest in higher data efficiency. Could we go to the next slide, please, Agnese? Thank you. To respond to that, the sector of data center users has already set itself self-regulatory initiatives. which is on the very good path to see and correspond to what's coming from the law. So data centers have already seen the trend, and they have already progressively set targets that existing data centers will achieve the same targets by 1st of January 2030 to meet the annual PUE target. And these targets apply to all data centers larger than 50 kilowatts of maximum IP power demand. So the sector of data centers sees the trend and has already set itself voluntary commitments. Next slide, please. So again, the self-regulatory initiative of data centers and server rooms will meet a very high standard, and they will look into the concept of clean energy to help data centers match their electricity supply through the purchase of clean energy, and also ensure that the electricity demand will be matched by 75% of the energy or hourly free energy by December 2025, December 31st, 2025, 100% of renewable energy or hourly carbon-free energy by December 31st, 2030. So also the self-regulatory initiative is very much on trend with regards to the Fit for 55 package in Europe and the EU Green Deal. Next slide, please, Agnesa. Thank you. So what the Energy Efficiency Directive now also does, in addition, is that the law, the legal trend, and the Energy Efficiency Directive is currently revised and will be ready and adopted by the legislators early next year. So the EU is really on trend to have more of a harmonized approach for data center sustainability schemes, so that there's more of a one-size-fits-all scheme and no fragmentation. Then the EU also looks to make the data center sustainability criteria mandatory by law to avoid greenwashing and to have a clear look on how data centers are doing, as they are big energy users. And then also the requirements for sustainability of data centers will be aligned with the taxonomy and the green public procurement criteria to promote circularity of refrigerants. So that's really, really important that data centers are also really aligned in the whole context of EU legislation. Next slide, please, Agnesa. And in Europe, let's have a look at data center cooling. We already have established the energy demand is very high. 3.2% of the total electricity demand is precast, and this is an official number by the European Commission. 3.2% of the electricity demand in Europe will be used by data centers. So, and that's set to be increased because data center technology will be increased. And so there is a need for data centers also to use more waste heat or do something with the exhaust waste heat to avoid overheating of data centers. And cooling is a solution for data centers. But cooling of data centers requires 40% of the energy that is used in data centers. And heat pumps can help to recover the heat for heat distribution via a district heating network to be connected to homes, industries, offices, and other types of end users. And that is exactly also what the Energy Efficiency Directive will demand. It will demand that data centers find themselves in a kind of network with other industries to create and to help more sustainable heating and cooling. And then high temperature heat pumps can use the exhaust heat data centers for heating purposes of buildings, of offices, of public buildings. And so overall, with heat pumps used in data centers, the need for fossil fuels will be reduced, and helps also to use or to set the energy used by data centers in a wider network. Next slide, please, Agnesa. We have covered this already. So the energy efficiency directive will now have an increased trend at EU level to have a higher energy efficiency target by 2030 of 30.5%, and that's a binding EU level target. Slide, please. What we also see, and it was mentioned before, we now have also a big geopolitical aspect for energy efficiency, and that's to get out of Russian fossil fuels. Just 3 weeks ago, the European Commission has adopted its Repower EU plan. They have set a target to be out of Russian fossil fuels before 2027. And to get there, the European Commission has reallocated 3 billion from the recovery fund to boost industrial decarbonization. And this Repower EU plan adds also an additional pressure on energy efficiency to go faster and to really use more waste heat, exhaust waste heat for heating and cooling of buildings, because overall that's the best energy efficiency we can do. So projects will have faster permitting structures, and the targets also increase for energy savings at an EU level from 9 to 13%. And then also for renewables, the targets is set to go higher from 40 to 45%. So coming from the geopolitical aspect, the existing legislation will have additional pressure. And with that, I hand it over to my colleague, Drita Gashi, and I thank you for your attention. Over to you, Drita.
Thank you very much, Christina. So my name is Drita Gashi. I'm a solution manager for BMS. And today I want you to show some slides regarding our solution, integrated solution and resiliently for data centers. Agnese, to the next slide. Regarding our solution, we have one, it's called Metasys. This is our building management solution. With that one, you can control the data centers. You can see there the status of data centers, and also some regarding cyber attacks that is increasing. And with our Metasys solution, you can protect yourself, also your data centers, regarding the cyber attacks. So you see that on the slide on the left side, some products, but also from the service activities. And yeah, as you know, in data centers, we have a lot of products there. You have products there from HVAC that we will also hear more from Lucia in the next presentation. We have also some from the fire, and also from fire and security and BMS. So in all that of products, so you have to bring to one solution to make it integrated. And all the kind of information that products are generating, you will receive that on the Metasys, on the software. And due to the user interface, you can control then your data center. So the big benefits, you see that on that slide. I want to go quickly through that because of the time. The biggest advantage, as I already mentioned, is the cyber attack to protect the data centers regarding that. So we are updating our Metasys solution regularly. And also another benefit that you have is that you can monitor and you can get reports directly to your computer, to your mobile phone. If something happened on the data centers, that you can control and react really quickly. And also the third point is that I wanted to mention is that we have the communication protocol BACnet. So if you have after 5 or 6 years another products that you want to integrate on Metasys, this is possible. So I would go directly to the next slide, please, Agnese. So I want to also to highlight one here, our controller. You see here one use cases from our side. You see on the left side some racks that you can as well control each racks inside. So you can control there the indoor air quality, the temperature, energy consumption that we heard a lot of before the presentations. But this is not only enough. So you have also to control the building itself. If something, for example, happens due to the floors, or someone don't have the access to go in data centers, indoor air quality as well, temperature in the building. So every kind of that issues you can control due our products and also as well from Metasys. So I would go directly to the next slide, Agnesa, please. So yes, and one product that we have is also PLCs in our portfolio, and I will show you the next slide. You see here one sentence, for example, data centers don't have the luxury of waiting out of the system for interruption. So that means in the end, if you compare that for the buildings, if you don't have their energy and the building is a standby, how to say, and so you have some times to act. But in data centers, the Gartner study, they make an analysis. So an average of the cost is more than $9,000 per minute. So that means for the data centers owners, you have really to act really quickly and to avoid any downtime on data centers. And this is the reason why we need as well PLCs on in data centers. So for the people that don't know what are PLCs, in the end, PLCs is a mini controller or a mini computer without a keyboard or a mouse or monitoring. And with PLCs, you can control the equipment like the HVAC solution and also security monitoring, window contacts, and so on. So let's go to the next slide to see what are really the benefits. Why PLCs? The most reason why PLCs, you have the redundancy in data centers. This is a key requirement for data centers, and also the reliability. And the third one I would highlight is the real-time monitoring in data centers. So if something happens in data centers, you can get the information in real time, so you're also not losing time, and also the low consumption of energy. So as you know, the challenge is also to reduce the energy in data centers, and with PLC that is also as well possible, but also to reduce the troubleshootings that you have in data centers. And so a lot of benefits for PLCs, but as you know, we have also alternative solution. But in this case, I would really suggest to go to PLCs because this is that the data centers have the requirements, and you have to solve that. And with PLC, this is possible. So I also want to highlight on the last slide from my side one use cases that we have in Germany. This is the Stuttgart University. We have there, they have some of the fastest industrial used computers in the world. And with Johnson Controls, we supported them to build it up, and they have some of challenges, for example, to reduce their energy consumption, to build a secondary building, to provide a redundancy solution, and also the reliability. And as well as we heard also from Christina before, the carbon footprint, which should be as small as it can, and that was possible from our side to provide together, so with them together and with our solution, the completely portfolio and to build it up. This is one of the use cases that we have in Germany. I'm not sure if you have some people here in the call from other countries, so if you're looking for another alternative or references from other countries, so let us know. So, and this is from my side today. Thanks for that opportunity, and I would hand over to Lucia.
Thanks, Greta, and good day, everyone. My name is Lucia Favuzzi, and I am HVAC Solution Manager for Continental Europe. Today, I'm pleased to give you a snapshot on our HVAC portfolio for data center needs. So the focus will be to present our core technologies that can help to gain energy saving and maximum uptime. Before to jump into the solution, I want just to highlight why HVAC system is so critical for data center. They get a lot of attention because they represent approximately 40% of the operating power consumption for a data center. So HVAC solutions must be equipped with the most advanced technology to improve data center energy consumption. But of course, it's not all about efficiency. For a critical environment, also maximum uptime and responsive service are everything. As JCI, we have a global team of more than 5,800 service technicians that deliver a high-end service for our equipment. But let's explore with next slide our HVAC core technologies available in our portfolio. We have diverse solutions for different data center sizes and dimension, covering a wide range of cooling capacity up to 11 megawatt and even above, including air-cooled chillers, water-cooled chillers with York screw, centrifugal or magnetic bearing compressors. Two key features I want to highlight here that are definitely the must-have for an HVAC system in a data center to be considered sustainable to the environment. The first is the refrigerant used, and the second is the operational efficiency of chillers. As you can see from the green icons, all our equipments are available with eco-friendly refrigerants, having low but even ultra-low GWP, like the 1233ZD and the 1234ZD. In addition, all our units are equipped with the variable speed drive as a standard feature to make sure that the chillers are able to work at a maximum efficiency, thanks to the ability to adapt the cooling capacity of the chiller to the real data center load, and therefore reducing the power consumption. We talked about heat pumps during the presentation and why they can really make the difference to enhance sustainability for data centers, because basically through a heat pump, it is possible to recover the heat and transfer it, for example, to the supply side of a district heating network. And the heat pump is needed to increase the temperature. And in our portfolio, we can also provide heat pumps as well, together with the air handling units and close control units. With next slide, I would like to mention some additional features of the screw portfolio of our air-cooled screw chillers, like, for example, the integrated free cooling water side economizer that helps to further reduce the operating cost when, for example, the outdoor temperature is favorably low for the operation of the unit. And last but not least, the very low time to restart after a power failure, thanks to a feature called Quick Start. Chillers are able to restart and reach the set point in a few minutes, reducing the risk of a very expensive downtime. With next slide, we will see the rest of the portfolio and some additional features on magnetic bearings and single centrifugal. As you can see, the quick start feature is available as well in this range. It's worth to mention here that this range provides a very wide operating map for a maximum temperature flexibility. And with regards to efficiency, we have here the YZ, that is the world's highest efficiency oil-free magnetic bearing centrifugal chiller. But let's say, however, having the world's highest efficient chiller is great, but not enough for a data center. Next slide, please, Inesa, thank you. And why? Simply because the chiller efficiency changes over time. Consider that a chiller has over 100 components that can impact their operation over its life cycle. And that's why maintenance is very, very important. Good example can be tube cleaning, reduced condenser flow, suboptimal refrigerant levels. These are all examples that can impact the efficiency. And we can estimate that up to 30% energy is wasted in chiller operation. That's why it's vital to address the energy waste over time. Let's see in the next slide how we can address. But before this, I just want to reflect with a few questions. What happens, for example, if a chiller is not running as expected, and how important is the operation of a chiller? And how much does it cost if a chiller stops working unexpectedly? These are key questions, very relevant for a data center, because we all know that the reliability of the cooling system is critical to uptime. But let's assume so that a chiller is not running properly, and let's see what happens. In a standard service process, the customer would call the service provider to explain the issue by phone, asking for help. Then the service technician would need to troubleshoot the problem, reach the site, understand what is the issue, then go back in the office, take the parts in case the issue is requiring a replacement. They then go back on site and make the repair. So everything is going well, the system is restored, but the whole process has taken between 24 to 48 hours. Let's see in the next slide our additional considerations. So this process is, let's say, nowadays outdated. And why? Questions again here. So what if the customer is alerted when the chiller optimal performance might be suboptimal? But what if the customer could even predict if the chiller might break down? We will see with the next slide how digitally monitored chillers can increase energy saving and uptime. OpenBlue connected chillers basically is a remote monitoring service to check the chiller performance from anywhere at any time. We basically collect all chillers data into Johnson Controls Cloud, and we provide remote access to the chiller performance and even notification through email or SMS, status check, health checks, reports, but last but not least, we provide data-driven insight useful to enhance the chiller efficiency and to run predictive and proactive maintenance. Next slide, please, Agnese. Then this is how the service turns, let's say, from a traditional process to a digital process. And you can see that the service process goes straightforward, and the time to resolution is reduced down to 3 to 4 hours with this solution. We can go next slide. So basically, with OpenBlue connected chillers, we move from dealing with emergency to a totally different approach based on avoiding emergency. Next slide, please, Nessa. So with this, let me conclude my speech saying that reducing data center CO2 footprint is possible through sustainable HVAC solution able to grant premium efficiency. But of course, it's not all about efficiency. HVAC equipments must be smart. And through OpenBlue connected chillers, we are able to guarantee that chillers work with maximum efficiency over time, but also with maximum reliability. This said, let me thank you for your attention, and I'll hand over to Agnese for the Q&A session.
Perfect. Thank you very much. Thank you very much, all the attendees and the speakers for today. We are a bit over time, so please feel free to drop the call, the webinar. We are going to continue just to answer to some questions. I forgot to mention at the beginning, we are recording the session, so at the end of that you will receive the full package with a recording of this session plus our forester report that Jan was introducing to us, and then you can just go through the recording if you are interested to the Q&A session. Please do not forget and take the time for a reply to our short survey at the end of this webinar. So let's see if there are some questions. Okay, I see several questions. Let me start from the beginning. So the first one is, the server temperature are normally not hot enough to be suitable for warming homes in winter and in summertime. No heating is required at all. Then how is it feasible to do waste heat recovery for residential heating in data centers? I will ask, yes, I will ask Lucia to take this nice question.
Yeah, thanks for this question. It's indeed very interesting. But let's say the excess heat can be transferred through heat exchanger through water. Then here heat pumps comes in action. What does it mean? It means that the excess heat transferred to a heat recovery, so to another heat exchanger. Then we have heating transferred to water and water coming through a heat pump. Heat pumps are needed to increase the temperature to a certain level, which is suitable for heating purposes or for other, purposing requiring higher temperature. That's the way to use the excess heat and to recover it.
Perfect, Lucia, thank you very much for the explanation. I'll move to the second question. So the second question is, how do we continue the trend on carbon efficiency for data centers? Experts? Jan, maybe you can...
Can you repeat the question, please?
Yes. So how do you continue the trend on carbon efficiency for data center?
Well, it's really the different steps we've been looking, the new type of design, suppressing fossil consumption, and really working on energy efficiency, on the use of the heat. Okay, like I said, 80% of the electrical power is transformed in heat to heat. And if you reuse this heat, you decarbonize the society, we use it somewhere else, in another industry, in also residential building. And the last point is renewable energy produced on site or in the surroundings, which creates, let's say, a better mix of electricity to be to decarbonize.
Perfect. Thank you very much, Jan. Let's move to the third question. As data center run the wall here, heat delivery to third parties should provide destinations in need of heat the wall here through, for example, public swimming pools, industry if needed heat, like hot water. I think, yes, this is more kind of a statement instead of question. I think, yes, very important statement over here. Fully agree on that. Thank you very much for this a note over here. So we still have other question. Let's move to the next one. Is there any solution aligned with circular economy? For example, upgrading existing equipment with VSD to make them more efficient? And that's very nice question. So who from the expert want to take this one?
Yeah, I think Lucia, you can bring it, but basically, the point is really upgrading the equipment with more efficient
units with VSD is a great a great tool to increase the efficiency, because we didn't mention a lot about the VSD during the presentation. The VSD benefits are clear regarding efficiency, because they enables any chiller to adapt the cooling capacity to the real load of the plant. So of course, VSD is a great retrofit type, and we usually offer it through our service technician.
We still have one last question, which is, do you also finance HVAC equipment?
Yeah, that's for me. Yes, through our JC Capital subscription, we have basically two programs, depending if the customer is willing to buy the equipment. So the payments are deferred over the contract term, with the duration that can be from 5 up to 10 years. Alternatively, we also have a rental option, and this is very interesting because if the customer wants to avoid the ownership, this solution enables to upgrade the chiller technology, replacing it in 5 years with the more efficient and new chillers. So this is connected with the need to improve efficiency and reduce operating cost over.
Perfect, Lucia. Thank you very much. I think you lost me for a few minutes.
Yeah.
Apologies for that. So the very last question is if we do have any reference list in Europe or Switzerland. I'll answer for this question. So the answer is yes, indeed. Also, Drita was showing to us one use cases that was in Germany for the Stuttgart University. We do have also other references, indeed. All the references that we do have available are accessible in our website on Johnson Controls. So please visit our page to understand more about our references and our and how we supported our customer for data center. Saying that, I apologize again because we are running out of the time. I hope you had a pleasant time with us, that you also find interested what we were discussing about today. As we said, sustainability is a very key topic, not only for data center, but specifically for data center. So that's why we wanted to take the time to discuss about this topic and show to you how potentially we can support this big challenge as a Johnson Controls. I would like to thank you also, all the speakers, all the experts for this session. Really appreciated your input. It was really a great information that you were sharing with us. So again, do not forget to take the time to answer to our survey at the end of the webinar. We will really much appreciate to receive your feedback in order also to improve for the next session. I wish everyone a fantastic day and thank you very much for your time.
Thank you a lot.
Thank you very much.
Bye.
Bye-bye.